Hello and welcome to this Next Week project. This is Natasha here from the Next Week team, and today we are doing day 4 of the DevOps AI series. So let's jump straight into the project. Here we go. Woo! In day 4, we're talking about automating testing with GitHub Actions. Have you used GitHub Actions before? Have you used CI/CD pipelines before? If you don't have any experience, if you're getting started, this is the perfect place to start. Welcome. And let's learn how production teams automate testing and automate deployment with CI/CD pipelines. That is truly, one of the core elements of CI/CD. Once you've really got a process figured out, and it is now just taking manual time to continue to repeat that manual process every time you want to test your app, every time you want to deploy your app. That's when CI/CD is an awesome solution. It's all about automating a certain process that you've kind of already put down into scripts that you can already start to run using, let's say, a server to run for you, so you're not doing it manually yourself every time. Okay, so this project is pretty spicy because it does touch on a few components. We're going to write a test and then we're going to automate it using GitHub Actions. It's kind of like a two-step process today. It's going to take you about 90 minutes if you're new to GitHub Actions. Add another 30 minutes if you haven't done the first few projects of the series. But the good news is it is completely free to do this project. The tool cost is $0. So let's go on ahead and have a little geeze of this 30-second summary. All right, welcome to project 4 of this 4-part DevOps AI series. Picture this. You've just learned how to containerize your app with Docker, which is what we did in project 2, and deploy it to Kubernetes, project 3, so it runs the same everywhere. Nice. But what if you forgot to run your test before deploying? What if bugs slip into production because you've only manually tested the most obvious scenarios and some edge cases come through in production? Once you've mastered containerization and orchestration, automating testing and deployment is your next challenge, and that's why CI/CD, which stands for continuous integration and continuous deployment, exists. CI/CD automatically runs your tests and validates code quality every time you push code, all without you touching a single command. It solves a big and common problem in production systems, and that's why tools like GitHub Actions, which is GitHub's CI/CD platform, have seen such massive adoption. In fact, developers used over 11.5 billion GitHub Actions minutes in 2025 alone, showing how essential CI/CD has become across the industry. Cool. So in this project, we're going to build a CI/CD pipeline with GitHub Actions that automatically tests your RAG app every time you update it. If you haven't done projects 1 to 3 of this series yet, no worries. You only need project 1, which is on building that RAG API for this project. Project 1 basically takes you through the thing that you're going to try automate the testing and deployment of. And that means project 2 and project 3 aren't actually required to do this project. You can either complete project 1 first, which we really highly recommend, or we'll guide you through a quick setup at the start of this project so that you can catch up. Either way works. I would personally pick doing project 1 first. But if you're thinking, hey, I just really want to jump into using GitHub Actions today, no worries. We're here for you, whatever you're keen to do. So by the end of this project, you're going to have a GitHub Actions workflow that automatically runs on every code push, no manual triggers needed. You're going to have semantic tests that verify your RAG API's answers and catches data quality issues like missing concepts. And deployment gating that blocks bad changes from reaching production. Okay, are you ready? Me too. I'm excited. So let's get into it. Awesome. So everyone learns differently, and in this project, you're so welcome to pick whichever track works best for you. We've got step-by-step guidance, my favorite, or the one that we always do in these project demos, where we go through every single click, every single step together. Great for beginners. If you're wanting a bit of more of a challenge, recommend that you go for the some guidance version of this project, where there's a little less guidance, a little bit more over to you on how you might achieve something. And on your own is when there's purely just the goals, the high-level goals for you to read and understand, and you can ask questions, and it really is more self-guided. You can always use Ask here to have as a buddy as you go through this project. So if you're doing on your own, highly recommend you have this open. So if you ever have questions, this is like a little prompt that can pop out a question for you, but it can always help you out and give you some tips along the way. All right, so with step-by-step guidance, we will be going through everything in a lot of detail, and if you ever get stuck, please know that the Nextweek community is here for you. The link to that is in the project guide. It's also in the description of this YouTube video. Okay. And here we go. All right, we're about to get started. And a great warm-up is to have a go at the quiz. So this quiz is here at the start of the project so that you can preemptively check out what are the kinds of concepts that are up ahead, and you're not expected at all to already know everything, but it's just fun to take a quiz and test a little bit of your understanding even before you get started. So give yourself some grace, give yourself some time to do this quiz, and just know that it'll come up again at the end of this project, so you can always have another go and see how far you've come just by doing a few things hands-on. All right, so with this quiz, question 1 says, in this project, what is OLAMA primarily used for? Well, anyone that's done the first few projects of the series, this is probably going to come pretty intuitively to you. OLAMA is the tool that we installed that helps us with getting access and running LLMs on our computer. And for the RAG API, we really need OLAMA because our API actually goes to OLAMA in order to process raw text and turn that into proper responses that we can send back to our user. So in this case, to run large language models locally on your computer sounds like the best answer here. Okay. Next up, what is the main purpose of using a Python virtual environment in this project? I actually really like this quiz now. It's a great refresher on a lot of things we did in project 1. And in project 1, we had to, what was that word called? Activate. We activated a virtual environment because virtual environments really help us with isolating the specific version of a Python package into a specific folder. And this is actually very important in the world of Python projects, because if different projects on your computer require different versions of the same tool, if you're upgraded to a certain tool, if you're, changed your version to a certain tool, maybe you did that so that this project can work, but now other projects are going to break. So Python virtual environments make sure that your projects don't rely on your system version of some sort of package, and in fact, the specific package or dependency that you've installed is isolated into this specific folder that you're running the project on. It also makes deleting these Python packages very, very easy at the end of your project, because all you got to do is delete the entire folder and boom, you've just uninstalled that tool too. So with that, it seems like to allow Python code to run on different systems without modification, does that seem right? Or is it this? To isolate, keyword, project-specific Python packages and prevent conflicts. That sounds good. Okay. Great keyword. I'm really liking this quiz. Okay, next question says, what does semantic regression refer to in the context of this RAG project? So semantic regression is such a fancy word, so many syllables, but it really just means, semantic means meaning, and regression means kind of going back or downgrading. So if you have semantic regression, it actually just means the degradation of the quality or meaning of the RAG system due to changes in the knowledge base. Yeah, it's like, there's this concept with data that's garbage in, garbage out. And same thing with RAG. If you load your RAG API's knowledge base with a bunch of trashy documents or answers or things that are inaccurate, then you best believe that your API is going to start outputting a lot of data that's inaccurate too, because it is referring to not the best kind of quality sources. So semantic regression just means, look, if you change your knowledge base, and that knowledge base is now less accurate or now has errors, you're pretty much enabling semantic regression because the quality of your RAG system is now going to downgrade overall. Okay, and what is the primary function of a RAG API as described in the project? Yeah, this is a good refresher of Project 1. And in Project 1, we created this RAG API, which is basically an API that you can just ask it questions. And what a RAG API can do is it can actually refer to documents that you've stored in that API as its knowledge. So you can create a RAG API that's specifically very knowledgeable about the definitions of Kubernetes and Docker and other DevOps kind of concepts. And then now your RAG API has a really great knowledge base and become an expert in that topic. The reason why it's called retrieval augmented generation is because it's retrieving relevant documents based on what you've already loaded into your API, or your API's knowledge base. And then it's augmented generation because after you collect all of the raw data or the raw text in your knowledge base that's relevant, your RAG API is going to pass it to Ollama, where there is an LLM running, and that LLM is going to process all of that raw text and turn it into a nice paragraph. I mean, it's kind of like, isn't it so nice that when you're using, let's say, ChatGPT or another conversational AI, that it can process a lot of information that it's scraped or that is found outside and turn that into a concise paragraph for you? RAG basically does a very, very similar thing, and that's why retrieval, augmented, and generation are all three are so important. So it seems like this answer B is our best bet. Let's have a go. Awesome. All right, question 5 of 6. According to the CI YAML workflow, which file's modification will trigger the RAG CI pipeline? Is it git ignore? Is it readme, requirements.txt, or Kubernetes or k8s.txt? So this is very, very project context dependent now. So I'll share with you the answer. It is k8s.txt, and it basically means that your GitHub Actions workflow is going to trigger automatically when it detects a change in your knowledge base. It doesn't require you to manually run it. It literally is just listening to your code, and when it sees a change, it's going to run it for you, and that just saves a lot of time. Nice. And why is mock LLM mode implemented in this project for CI/CD testing? Wow, we're finishing off this project with kind of very, very specific questions for the steps up ahead. But mock LLM mode basically means that we are going to be creating some testing for our API and whether or not the meanings of the words we're going to test it against, we're going to test what is the meaning of Kubernetes and test whether or not the RAG API is outputting the correct kind of answers and whether or not it's covering all of the meanings of Kubernetes that we want it to cover. So mock LLM mode becomes, we're going to implement this mode in our project because we're going to see that it's going to be very, very hard to try test whether or not an LLM is covering keywords or semantic meanings every time it's generating a response. By definition, like LLMs, they're always just kind of predicting words based on the information that it has. And because of that, the answers that it can generate can be so random. So how can you test every time you test your API whether or not, if it's generating the correct response or not, whether or not that's because of your knowledge base or whether or not it's because something happened during generation? So mock LLM mode is going to be a solution that we use to help resolve that. But yes, The more technical kind of words that we're going to use to explain it is to allow the API to return the retrieved context directly, ensuring deterministic test results. And this is going to make a lot more sense when we get there in the project. For now, it's really just about resolving uncertainty. Okay, so let's complete our quiz. This looks great. Well done. We just mastered that quiz, crushed it. And let's get on with the hands-on project. So in this project, we will demonstrate how to use GitHub Actions to automate a workflow for our RAG API. The workflow we're automating is about testing the performance of our API in terms of semantic meaning and catch any semantic regression We're doing this project to learn how to use GitHub Actions and how to test the results of our AI RAG API. Nice. Okay, so before we build your CI/CD pipeline, let's just make sure you have a working RAG API working. Whoa, let's make sure you have a working RAG API ready. So if you've done project 1 of this series, and in this demo, we're gonna assume that you have, this will be super quick. If not, no worries. We're gonna set up each component as we go, and the steps for that are all in the project guide. So definitely grab a copy of this. The link to that is in the description of this YouTube video. And here's a recap of project 1. So in project 1 of the series, we learned how to create a RAG API. This means you built an API that can use AI to understand your documents and answer questions about them. You wrote code to load your knowledge base into Chroma, our database. Then you created a fast API app that uses Ollama to give answers using your own data. Okay, and a RAG API is a way for different programs to communicate with each other and answer questions. That's what APIs do in general. It's a way for two pieces of software to pass information with each other. And a RAG API is an AI-powered API that answers questions by retrieving information from your knowledge base, augmenting a prompt with that retrieved context, and then generating an answer using an LLM. So retrieve documents, augment a prompt you pass to an LLM using those docs, and then generate an answer using an LLM. Awesome. So in this step, we're going to set up your RAG API's code, database, and dependencies, and we're also going to test the RAG API locally. All right. So in this step, we're setting up our RAG API, which is an AI-powered API that answers questions by retrieving, augmenting, and retrieving relevant information from a knowledge base we built then augmenting and generating a response with an LLM. We need to set up this RAG API before we build our GitHub Actions workflow, because our workflow will be about testing and deploying, will be about automating testing and deploying this application. It will need to work before any automation or any testing or any deployment happens. If your RAG API doesn't work, then what are you testing or deploying? Let's make sure that at its foundation, it's working first before we try to add all this sparkle and shine. Cool. Now, to open up your project, let's open Cursor on your computer. In your Mac, let's press Command Space to open Spotlight and type Cursor and press Enter. Beautiful. Oh, I'm showing you another project. Spoiler. Let's open up the blank window. Here we go. So when you're in Cursor's welcome screen, why don't we actually split screen again today so we can see our instructions? Okay, so Cursor's going to open up on your screen, and have you completed project 1 of this series? Yes, you have? Then perfect, welcome back. No, you haven't? That's okay. Here's a setup guide that can get you up to speed. So if you've completed project 1, let's go ahead and select Open Project from the welcome screen. And then we're going to navigate to the RAG API folder, which is over here. Select that and open that up. Your project should open in Cursor, showing your Python files over here. All right, and this looks great. We've got a bunch. Oh, just realized this should not be here. 1 second. Apologies, everyone. But once you've got your project open in Cursor, there are a few files that we're just going to double check that we've got. Okay, so first up, let's make sure you've got your app file, which defines your fast API application. This file is so important to make sure that your application is retrieving, augmenting, and generating. This file defines all of those parts of the app. So it's pretty much very core to your RAG API. You've got embed, this Python file, which is a script to create embeddings. And embeddings is basically the kind of like the numerical representations of the words that are in your database or in your knowledge base. So it's very important. It's a very key part for our RAG API to actually retrieve the right kinds of information based on your question. You've got Kubernetes text, which is your knowledge base document. And I have a feeling that might not be showing here, but let me grab that. 1 second. Okay, I've got my folder all set up properly now. You should have your app file, your embeddings file. You should have your Kubernetes text file. There's your virtual environment, which includes all of the packages you've already installed, and as well as your database that contains the embeddings for the Kubernetes text file. These are all things that we set up in the first project. And if there's anything missing, don't hesitate to switch over to the other tab where you can just go and complete all of the setup from scratch. I promise it doesn't take too long, and it's actually a lot of fun and you learn a lot during that process. Okay, so once you've made sure that everything is set up correctly, we're just gonna go ahead and test that your RAG API works too. So make sure your virtual environment is activated in your terminal. How we can do that is we can open a new terminal from here. All right, and we're just gonna activate it. So you can go ahead and run this command here to activate your terminal. And once that's all activated, all you gotta do is run this command for running your RAG app. There we go. And once that command is running your RAG app, the next thing is to actually query your own app and see whether or not it gives you the correct results. So as a reminder, in this project, the document was about Kubernetes. And what we're gonna do when we ask what is Kubernetes is make sure that our LLM is actually here to say, okay, there is a Kubernetes project, which is a container orchestration platform used to manage containers at scale. Beautiful. That's exactly what we wrote in our document, confirming that our RAG API is capable of retrieving this document, augmenting a prompt to an LLM, and then generating a proper response back to us. So for the rest of this project, it's all about automating the testing and deployment of this app from here. Cool. All right, let's take a screenshot of our terminal, which is showing the successful API response with an answer about Kubernetes. Beautiful. Off we go. And how did you verify that the RAG API is working? We tested our RAG API by running it locally, then querying it and seeing if it provides a proper response about Kubernetes. Oh, we're gonna we queried it about Kubernetes, and then we checked if it provided a proper response about it. The API responded with a paragraph containing a description of Kubernetes we added to our knowledge base. This confirms that our RAG API is capable of retrieving, augmenting, and generating a response. Beautiful. Okay, so your RAG API is working, and we're now going to go ahead and push this code over to GitHub. GitHub is this platform for hosting and collaborating on code using Git version control. Think of it like Google Docs for code. It helps you to track every change you made to your code base. It lets you collaborate with others. It's where so many developers store their projects. If you're not on GitHub already, highly recommend you create that GitHub account, and let's get started. Cool. And what is Git? So Git is a version control software that tracks changes to your code over time. It lets you save snapshots of your project. So in these snapshots are called commits, revert to earlier versions, and work on features without breaking your main code. Ooh. So Git is the version control software, and GitHub is the platform that basically lets you use Git and also see other people's repositories online. And in this step, we're going to be initializing a Git repository. We're going to create a GitHub repository and then push your code to GitHub. Beautiful. So in this step, we're initializing a Git repository. Git is a version control system that lets us track changes to our code. We need it because we can use that to revert to earlier versions of our code and work on features without breaking our main app. So that seems pretty useful. especially when we're creating some sort of automation where we're testing things, we're building new things. It's going to be very easy for our code to, let's say, change in many different ways, and it might be hard to actually revert back to what it used to be. Also importantly, we're going to be using GitHub Actions, which works on code that is stored on GitHub. So you definitely need your code on GitHub first in order to use the automation tool we're using today too. Awesome. So let's save that. And we're going to initialize our GitHub repository. Follow along as we go through these steps. If you haven't used Git before, definitely recommend that you just continue using Ask to ask questions and help you along the way. Otherwise, let's charge ahead and initialize a Git repository. To do that, we're going to make sure, and I'm going to run the command clear, which is just going to help refresh my terminal so it looks nice and fresh. But where this all starts is first checking that you're in the right directory. So we're going to run pwd, make sure that we are in our project folder, and then we're going to initialize a Git repository by running the command git init. Okay, and this is going to return a response in the terminal that basically gives you a big hint about the name of your repository or your GitHub repository's branches. So when you run git init, Git creates your first branch and names it master by default, but lately there's just been a trend towards renaming that master branch to main. And for this project, we're just gonna stick with master, but if you're interested in knowing the context, why there's all these hints about perhaps using main or using another kind of branch name, it's actually more about using inclusive terminology. There was a bit of controversy about the word master and any connotations with that word. So I think this hint is all about just making sure that you've got options if you'd like to change the name of your repository or your Git repository's branch. Main is the most popular one today, but we'll see how things develop in 20 years. And for context, branches are a key concept in Git. It basically, every version of your code is a separate branch. You can think of it in that way. So when you're working on your code, you can actually switch between branches in your same repository so that you can suddenly switch branch, different version of your code, work on that to test a feature. And then if you're thinking, I want to create another new feature based on the main version of my project, like the base version of my project, you can again create a new branch and go from there. Okay, so before we commit our code, we're going to tell Git which files to ignore, like virtual environments and databases. And we do that by creating a file that's called gitignore. And this file is basically telling Git, please track changes to my code, but ignore these files. The reason why you'd want to ignore files is because your virtual environment is a huge file. Huge. If you want to track changes to it, I think your Git history is going to start looking really messy. And it's totally okay to track big files. It's just that virtual environment is big in terms of having thousands and thousands and thousands of files. And typically you don't need to track it. You just need to make sure that you can install all of the dependencies that you need in whichever environment that you're running your project in. So you can ignore virtual environment, and you'd also want to ignore any sensitive data. So common in many apps is this file called the environment file, which you'd use to track environment variables like API keys or confidential secrets. And you typically want to ignore that file too, because you wouldn't want Git to start tracking it and then uploading that code onto GitHub where other people can access your code and all of those secrets too. All right, and that's the reason why a gitignore file is so important. And to create that file, let's just name that .gitignore here. And we're gonna go ahead and paste this content over here. All right, save that. That creates our gitignore file. And whoa, let's see. You can see we've got our virtual environment and the Chroma database in here. This Chroma database folder contains your embeddings. And again, we ignore that because actually in CI/CD, when we're continuously integrating, deploying, the workflow is going to be building our database every single time it automatically runs, and that means we don't need to commit it. When you pull someone else's RAG API, let's say, you'd also be expected to just build your own database as well, instead of downloading someone else's database. Chroma databases can definitely scale with the number of documents that you have, so just having the raw documents themselves is enough. If you were to download their Chroma database too, that's going to become a huge file. Okay, so we've got other files in here too, and they all have their own reasons, so you can definitely read this and check out what are all of these other files that we're ignoring. You might notice that there are some IDE specific settings and configurations, so not all of these is going to be relevant to you, but we've decided to kind of create this catch-all git ignore file. So depending on whatever setup you have, you should still be able to have only the necessary files stay, and git ignore kind of covering and handling the rest for us. Okay. So once all of this is ready, we just need to stage our file. So that looks like this command, git add dot. And staging basically means preparing these files for a commit. So committing basically means kind of writing this into your Git history. And it's a bit of a big moment because Git histories pretty much cannot be unwritten. Once it's written into its history, it's really there for you to come back to, even if you delete that file later on, even if you do something completely different in the future with that file. It is very hard for you to even undo things. Typically, once you've committed something into your history, even if you wanted to undo it, it doesn't delete that commit, you actually just revert back. And that can happen without you needing to delete things from history. All that to say, git add is just about preparing these files for being saved in your Git history. So staging is an important concept because you might notice that when you're working with Google Docs, you simply just press Command S, or you don't even need to save, it just gets auto-save. But a lot of your documents, you press save and that's it. You've kind of like saved it into history already. But in Git, you would introduce this stage called staging because staging allows you to actually control what documents you want to commit. So if you're working on 50 files, you can actually just choose to commit 3 of them that you actually really want to save in your history. And then the other 47 are like, oh, I'm just playing around. I don't really want to save all of these changes. So staging lets you also have control over what you save. Staging lets you control what you save. Okay, so you can check what's staged, which basically helps us confirm that we've staged things correctly using git status like this. And here you can see that we've got a few changes that are going to get committed. You've got git ignore, you've got an app file, embeddings file, and the Kubernetes text file. If you see more in your list, you might see Docker file in there or deployment YAML. All of these are other files that we would have used in previous projects of this series, and it's totally fine if you'd like to save those in your history as well. You're not going to run into any issues. Don't you worry. Okay, so we're going to now commit the code, which is basically writing it into our Git history. And how we do that is by running this command. So we've got git commit -m, initial commit, set up local API project. So this -m flag basically helps you tell Git, hey, I've got a message for you as I save all of these things into my Git history. And the message is, and this is what you write in your brackets, in your quote marks. You just write whatever commit message you've got, you press enter, and now it's saved into your Git history. Cool. Great. So question time. What did we accomplish by initializing Git and creating your first commit? We initialize Git by running the command git init. A commit is a checkpoint or or a version of our code that we've written into our Git history. And the git ignore file helps by making sure unnecessary files don't get included in our Git history. Sweet. Okay, so now let's create a home for our code on GitHub. We're going to do this by opening our web browser, going to github.com, and I might just go ahead and split up this now. Okay, so that you can see both sides. Once we've signed in, I'm signed in all here, you can click that plus button in the top right corner and select new repository. Cool. And for the owner of this repository, choose your own GitHub account. And then the repository name should be Nexthook RAG API. It's always good practice to just choose the same repository name as what it's called locally, so it's very easy for the two to refer to each other. And it's honestly easier for you to match up. Okay, this folder matches up to that Git repository too. And then we've got a description. This repository stores a RAG API with a CI/CD pipeline. And for our visibility, we're going to choose public because public repos get to use GitHub Actions for free. And I think that's a worthy trade. Now, we don't need to initialize this repository with a README. We just need to go ahead and click Create Repository. Okay, so once it's created, you should see the setup page that looks a little blank like this. That's perfect. It's good to start with a blank slate on GitHub. Now, we have just created an empty GitHub repository, but our local Git repository is full of files. We've already created our RAG API. We're ready for testing. So what we're going to do next is connect that local Git repository to this GitHub repository so that the code can be pushed into GitHub, and now GitHub can become your online storage space for all of your all of the different versions of your repository's code. All right, so to do that, we're going to find that section that says push an existing repository from the command line, because that's what we're using. We're going to push an existing repo, which is our RAG API repo, into this online GitHub repository. So copy the first line in your SSH repository URL. It should look a bit like this. Okay. And this command creates a connection between your local repository and the GitHub repository. So it basically just says, let's add in our local repository a new online version of our repository, you can say, a new online GitHub repository, and we're going to call that repository origin as a nickname, so we don't need to write this out every single time. But this is the actual URL or the actual address of the GitHub repository that we want to connect to. So after running this command, whenever you use origin, Git knows that you're referring to a GitHub repository. Awesome. And let's paste this command into the terminal like this. And we're going to now test our SSH connection. So we're going to copy this command that tests our SSH connection. We're going to run that in our terminal too. And for me, you can see it says, "Hi Natasha, you successfully authenticated, but GitHub does not provide shell access," which is this tab over here. And it basically means that we can't log into GitHub's servers, which is usually what SSH does. But in this case, GitHub SSH is being used to actually authenticate us to GitHub, so at least we can run some other Git operations, like git push or git pull. This is a good thing. It's totally okay to see this. It actually matches up with what we need. We don't want to log into GitHub servers. We simply want to push and pull code into our GitHub repository. So what we want to do next is just run this command here and see the results that tells us, hey, what are our remote repositories? What online, like digital repositories, are connected to this local repository. And we can see that because we have used git remote at origin, we've successfully made sure that over here, that we are able to connect our local repository with this GitHub repository too. And this GitHub repository is called Network Rag API, which is exactly what this repository is called. So now you know that when you push your code into a remote repository, it's going to get pushed into here. Very nice. So with that said, let's push our code up. And this says we're going to create, we're going to set our default branch name to main. And then we are pushing our code now up to main. Now that we're mentioning that we're going to rename our branch to main, I realized that before when I mentioned that we're just going to keep the name master for our branch, that was incorrect. We've actually renamed our branch from master to main. So if that was confusing, please know that we have just renamed our branch over to main. Okay, so you should see output that looks a bit like this. And that basically sets up tracking, so future git push commands know where to push. And honestly, this kind of output, there are a lot of different kinds of explanations here. You don't need to know everything. Honestly, I've been using git push for years now, and I never really thought about like, hey, what does every single line mean? But you can always explore your curiosity, and that's a great idea. So here are a few explanations on every single line if you'd like to learn more. And if this is your first time using Git, you also just need to configure your name and email. This information will be associated with your commits. So let's check if Git is already configured on your computer. We're going to run these commands to check your current Git configurations. So these commands show me that I've already got a name and email associated. So I'm totally fine. I see my name and email, I can move on. But you can also select I see nothing or an error if that's what you see, and then configure Git. That's totally normal too. Sweet. So you should now see your files on GitHub because we've already pushed our code up to our remote repository. So we're going to head back to our GitHub page. Let's refresh that. And ta-da! Very, very well done. You can see that all of these files, all 4, are now on GitHub. Congratulations, your RAG API is now on GitHub and you're ready for CI/CD. Great. We're gonna go ahead and take a screenshot of your GitHub repository showing your pushed files like this. And then let's answer this question. Pushing to GitHub means making our code available means making our code available in a GitHub repository. The benefits include having a backup of our code online, being able to publicize, being able to make our code public so we can collaborate with others. This enables CI/CD because we can now use GitHub Actions. Great. So in step 3, we're going to start to create tests for our RAG system and see how it performs locally. And semantic tests basically tests for the meanings of the output that your RAG API gives us. Is it actually producing answers that covers all of the meanings that we wanted to cover? In our case, we're going to see that if we want to create a semantic test for this RAG API about Kubernetes, we'd want to test whether or not it's actually providing information about containerization. Is it providing information about orchestration? If its answers can include those keywords, then you know that the answer that your RAG API gives you isn't too far off. It's kind of giving you a pretty accurate definition. If it was far off, it was, before we added this RAG API, before we added like documents about Kubernetes, our RAG API was giving answers that Kubernetes is a dessert or it's a game character. And, that's when okay, the words orchestration and containerization aren't in this answer, something's off. So in this test, we're creating semantic tests. Semantic tests check for the meaning of, I would say, of the answers that our RAG API system returns us. These tests are different from unit tests because we're testing data quality and not just code correctness. Great. Awesome. So to create that test that checks whether or not our RAG system is retrieving the correct information, we're going to create that semantic test script. To do that, in Cursor, we're going to create a new file and we're going to name it semantictest.python, like this. And then we're going to paste this content in here that lets us test the semantic meanings of our RAG API's responses. Okay, so this code verifies that your RAG API is returning semantically correct answers. Here is a bit of a code breakdown, but the most important part is that instead of checking for exact text matches, it doesn't test exactly like, do you say Kubernetes in this exact way? It actually just checks for key concepts over here. So the two key concepts we're checking for are orchestration and container. All right, and we're going to save our file and we're going to now test this script locally. So to do that, we're going to make sure our RAG API is running in your terminal. Let's start it up, and we have this terminal that's been running our API for a little bit now. And what we're going to want to do next is make sure that we're going to test our API in a new tab, and then we're going to run the semantic test. Okay, so best to actually just, I personally like to just rerun the API myself, even if it's already running in a terminal. Typically you don't need to. What is really good about -- reload is that it automatically reloads itself whenever it sees code changes or new files getting created. So that was honestly just out of pure habit. Didn't think I'd be doing that in front of the camera. I think I just did it. But you don't need to Control-C and then run that command again. You can totally just run the semantic test. Ooh, sorry, my computer's glitching at the moment. Okay, and we just need to run that command, Python semantic test, in a new terminal tab. So we're going to go over to a new terminal tab. Okay, sorry, my RAG API is running here. I'm switching over to this terminal tab. We're going to activate that tab too. And then we're going to test this Python script in that new tab. Okay, so what is going to happen now? Let's see. Aha, all semantic tests have passed. Very good. And that's because Kubernetes.txt contains both keywords, orchestration and container. So what would have happened here is that the response that your RAG API generated when it queried what is Kubernetes actually returned proper responses containing container and orchestration, and your semantic tests have passed. Very nice. So we're going to switch our terminal back to the first terminal where you're running the RAG API, and we're just going to go ahead and stop the API server. You can press Ctrl+C in the terminal, and well done. This test script works and passes because your Kubernetes text file still contains orchestration, but let's see what happens when we break the file. So let's break the file. We're going to go ahead to our Kubernetes text file, and we're going to go ahead and break it. Hey, let's see what happens now. So to break it, we're just going to remove a single word, orchestration. So it looks like this. And what that means is a key concept of Kubernetes, orchestration, is now gone from our own, It's now gone from our own knowledge base. So this is the start of that semantic regression that we talked about in the quiz. The meaning of Kubernetes is now no longer as accurate or as good quality as it used to be. So because of that, when our RAG API is now going to try define Kubernetes in its future responses, it's not going to look too good. Because our semantic test script literally tests for whether or not we include the word orchestration in our answer, technically this test should now fail, because our RAG API should no longer be including this word in its responses. To rebuild, to actually test our RAG API properly, now that we've deleted the word orchestration, we're going to actually need to rebuild the embeddings in our knowledge base so that they reflect the updated content. Okay, and embeddings are numerical representations created from your source text. When you change the text, Kubernetes.txt, the old embeddings actually still represent the old text. They don't automatically update. So if you update a book's content, you're definitely going to need to create a new index that reflects the new chapters and topics. So when you change your knowledge base document, you're going to need to regenerate the embeddings so your RAG system can find the updated information correctly. All this to say, whenever you add new information to your knowledge base, make sure that you refresh your embeddings too. And embeddings, as a recap, are basically the numerical representations of the meanings of the words in your knowledge base. So you definitely need to make sure that is reflective of the current state of your documents. Otherwise, your RAG API is not truly providing answers based on your text files. It is just providing these answers based on those embeddings. Okay, so, oh, my computer, it's crashing again. 1 second, team. Sweet. So we're going to do this by removing our old database to ensure a clean rebuild. Okay, let's run this command in our terminal. Okay. And deleting this folder, make sure that we start with a completely fresh database. This guarantees that the new embeddings reflect that updated Kubernetes text file, which does not contain the word orchestration. Awesome. And then we're going to run that embedding script one more time so that we're re-embedding our Kubernetes text file. Okay, so the embeddings are stored in Chroma. As you can see, we've got our DB folder back. Very nice. And we can now test our API again. Let's return to the terminal tab where API is running. We're going to press Ctrl+C to stop the API server, which you might have already done. And then we're going to go ahead and start your API again by running the command reload. Okay, by running the uvicorn app command. And then That means that in that new terminal tab, we can test the API directly again using curl like this. So we can see the results. You know what? I'm gonna refresh my terminal so it looks like this, so you can see the output easily. All right, so you can see from the results here that we've got the definition of Kubernetes here, and it says a container platform that provides automated management scaling, and actually the word orchestration still slips through. Let's try again. What is Kubernetes? Kubernetes is a term coined by the Kubernetes creator. Okay, we're definitely not including the word container or orchestration, so this is a fail on both. Try again. What is Kubernetes? A popular container management platform used to manage containers at scale. Now it's perfectly retrieving our knowledge base document. Try one more time. It's a container platform used to manage containers at scale. Again, this is a good retrieval of our knowledge base, but you can see that the answers really vary. Sometimes it includes orchestration, even though we removed it from our knowledge base. Sometimes it doesn't include orchestration, and the output varies every time you run that same query. Okay, so what's happening here is called non-deterministic LLM behavior. The LLM that we're using behind the scenes, called Tiny Llama, was trained on data that could have included Kubernetes and orchestration together. Even though your source document no longer contains orchestration, the LLM sometimes adds it based on its training data. And this is a fundamental problem for testing. The same input could produce different outputs, and now tests become unreliable. They can pass, they can fail randomly, and CI/CD really can't work with non-deterministic tests because you're really automating a lot of uncertainty. So because of this, we're gonna again go back to the terminal where the API is running and just stop that. And that concludes this step. Can we automate tests with non-deterministic behavior? No, because if you automate your tests to run automatically, it runs and checks your code, and tests fail, but only sometimes. You can't tell if your code is broken or if the LLM is just generating a different response. You really start to lose trust in your automated tests, and you start ignoring the failures. When that happens, your automated tests become useless. And that's exactly why we're going to create a solution locally before we start to build and automate these tests. Cool. So when we ran the query multiple times, we noticed that our RAG API's responses are very random, even if our knowledge base is missing a keyword, orchestration. Our LLM can still generate that answer in its responses. This is a problem because the results of semantic testing also become random. It could be failing or succeeding because of our knowledge base or because of our LLM. For CI/CD to work reliably, we need deterministic outputs, i.e. outputs that are clear, that give us clear conclusions. Cool. Okay. Oh, I think we scrolled a bit too far. Okay, so in step 3, we discovered that LLM outputs are non-deterministic, and the same query can produce different responses every time. This makes automated testing really hard to trust. So our solution is something called mock LLM mode. Instead of using the LLM to generate answers during testing, we'll actually just make our API return the retrieved context directly. So what is retrieved context? Retrieved context is the actual text chunks from your source documents, like kubernetes.txt, that the vector search finds when you ask a question. For example, if you ask, what is Kubernetes? The vector search actually looks through your embeddings and retrieves the relevant chunks of text from kubernetes.txt that answer your question. These text chunks are the retrieved context, the raw information your RAG system found before the LLM processes it into a final answer. So in mock LLM mode, instead of sending this context to the LLM to generate a polished answer, we're going to get our app to just return that raw retrieved text chunk directly. This lets us test whether or not we're just even retrieving great information, which in turn tells us whether or not our knowledge base is good. It pretty much takes the LLM out of the formula, out of the equation, so we're no longer confused if the word orchestration or containers are missing. We're no longer thinking, wait, is it because of the LLM or is it because of the knowledge base? We now know with certainty, that is because of the knowledge base. Okay, so to do that, we're going to in this step, we're going to test the API locally with that mock mode, and then we're going to commit and push that mock mode implementation. Okay, so here in this step, we're adding a mock LLM mode to our RAG API. A mock LLM mode flag allows our API to work in 2 different modes, i.e. with mock LLM mode on or off. This mode is will solve the non-determinism problem by making the RAG API just return the retrieved context before passing any info to an LLM to generate a response. This gives us clarity that if the RAG API fails to retrieve the words orchestration and containers, it's because of our knowledge base, not because of our API. Sweet. So with that, let's move on to adding that mock LLM flag to our app. And we're going to open our app over in Cursor. Okay, and then we're going to replace the entire content with this updated version that includes mock LLM mode. Okay, and all it does is it says that if we're using mock LLM mode, please just return the retrieved context. If you are not using mock LLM mode, then then pass the retrieved context over to Ollama to generate a response. Okay, so let's verify whether or not mock LLM mode actually works. In this case, we don't need to rebuild our embeddings because we've already broken the Kubernetes text file and we've already rebuilt our embeddings. So what we need to do is to just start our API and test it again, but this time in mock mode. Sweet. So we're going to run this command, which is to use mock LLM mode to reload our API. So let's reload it. Beautiful. Now we're just running our API again, but this time in mock mode. So prepare to see the retrieved context instead of seeing the generated response. So let's go ahead and actually try. I wonder what's going to happen if we just Oh, great. I mean, here you can just see the retrieve context. It just grabs whatever was in that Kubernetes text file straight away, which is pretty handy. In our case, we're going to switch over to our second terminal, and the real test comes when we run our Python semantic test one more time. And let's run it over here. And you should see this error, assertion error, missing the orchestration keyword. Run the test 1 to 2 more times. One more time. And there we go. This time the test is failing consistently. And that's exactly what we want. We want to see determinism, which is like consistent fails, consistent results if you give it the same input. So in this case, we just keep giving it the same input, which is the same knowledge base, and you can see that the results are also consistent. Beautiful. So the test is failing consistently. It says you're missing the word orchestration, which is exactly right as well. So we're gonna go ahead and stop our server again. Okay, and perfect job. We now have deterministic tests. So mock mode solves the non-determinism problem by so mock LLM solves this problem by making the RAG API simply return retrieved context, and in mock mode, the API returns the Kubernetes file directly. This makes the test deterministic because now our tests are consistently failing because the output consistently misses the word orchestration. Okay, so now that mock mode works locally, we're just going to save that to GitHub. So we're only going to commit this app file, the changes to the app file that we've made that enables mock mode, because we're going to be using the Kubernetes text file. We're going to be using this file for another purpose later on, which we're going to see. Okay, so to do this, we're going to add the app file to staging. And then we're going to commit our changes over here. Nice. So this commit, this save, is basically saving into our Git history that we're going to add this mock LLM mode. And now we're going to push it over to GitHub. There we go, Git push. Great, so your mock mode is now going to be on GitHub. So we're going to go ahead and respond to this answer here to wrap up our work for step 4 and then move into step 5, which is all about automating these tests with GitHub Actions. So here we're just going to remind ourselves, this is super important, mock LLM mode and how it works. So this might feel a little bit familiar, but it's always worth recapping. That mock LLM mode works by retrieving the direct context of our LLM. Semantic tests check for the meaning of our RAG API's responses. This is important for CI testing because we can now automate deterministic tests. Woohoo! Okay, so what's next? You've successfully implemented mock LLM mode, which solves the non-determinism problem we discovered in step 3. So your API can now run in production mode with real LLM generation for users using Ollama, and also in mock mode that uses deterministic output for testing. So because of this, the difference between production and mock mode. To summarize what we just implemented, mock LLM mode equals 0 would mean that we're using Ollama for natural answers, and mock LLM equals 1 retrieves just the retrieved context for deterministic testing. This pattern lets you test data quality without the variability of LLM generation. So in step 5, we're going to put this all together by creating a GitHub Actions workflow that uses mock mode for automated testing. Nice. Okay, so in step 5, we're going to create that GitHub Actions workflow, and then we're going to trigger the GitHub Actions workflow and watch it actually succeed. So this step is about setting up that workflow, and then step 6 is to watch it work. So let's create that GitHub Actions workflow first. The best part is honestly we've solved the hardest problem already. The non-deterministic LLM output was really the hardest part. And now that that's out of the way, creating that GitHub Actions workflow is just about automating that. And then we're going to trigger that workflow and watch it run in GitHub. Very nice. So in this step, we're creating a GitHub Actions workflow that automates our testing. A GitHub Actions workflow is, here, it's basically a YAML file that describes some steps that we should do, like install Python or run tests. And what it does is GitHub automatically runs these tests or these workflow instructions on their servers whenever the code changes or whenever, based on whatever trigger you define. So it's how companies deploy code hundreds of times per day. And in this one, we're going to just automate how we test, that semantic testing, with our GitHub Actions workflow. So GitHub Actions workflow is a YAML file that describes what to do. And GitHub will run it automatically on their server based on triggers you define. Okay. All right, so we're going to create that workflows directory. Over here in our File Explorer, we're going to create that special folder that's called .github/workflows. And once you've created that folder, we're going to create a file called ci.yaml, which means continuous integration. And then we're going to paste that content that defines our workflow. Let's break down this file a little bit together. So we've got the name of our workflow. It's a RAG CI pipeline. We've also got a trigger. So whenever we push and there are changes to our Kubernetes text file, if there are changes to our app file or the embeddings file, our workflow gets triggered. Our GitHub's going to say, oh, something's happening. We're going to have to run this workflow. And then once that trigger happens, what it runs is this, the steps here. So these are the automatic steps that are now going to happen when our workflow gets triggered. But the thing before here is that there's like a runs on thing, runs on component of this workflow file, which is basically a runner. Think of it as like a computer that GitHub is using, or the server that GitHub is using to run these tests. And then here are the steps, which are the steps that the workflow performs in order. These steps should look a little bit familiar. You know, we've got downloading the code, setting up Python, rebuilding your embeddings, installing your dependencies, starting the API in mock mode, okay, so that we're just retrieving the context and we're testing it properly. And then we're going to run that semantic test file. So if it all succeeds, the message at the end should say all tests passed, RAG quality maintained. Very nice. So let's commit and push this workflow file and test script into GitHub. Okay. All right. And what we're doing now is we're just committing, which means saving the Python test file and also the workflow file that we've just created. So we're going to run these commands and press enter like this. Nice. And then we're going to commit this workflow and the test script. So we've added it to staging. We're now committing it. Do you remember what's next? It's add, commit, and push. So the last thing we're going to do here is push that up to our GitHub repository. Very nice. So let's check that the workflow file is up on GitHub. We're going to go to our GitHub repository in our browser. Okay, it should look something like the URL should look something like this. We've got it over here, so we'll open it up here. Beautiful. And click on that Actions tab in your repository page. Well, since we've pushed our workflow, surely it's going to start running. Come on, GitHub Actions, do your thing. Automate this test that we've just created. You might notice that nothing's running. What's going on? So the workflow only runs when you change Kubernetes text, the app file, or the embeddings file. But we only just pushed the workflow file and the semantic test file, which isn't one of those files. So notice that in our CI, in our push here, the trigger, we'd say, okay, trigger this action automatically when one of these three files change. But the file we pushed was actually our CI YAML file and the semantic test file. You can see neither of those are included in this trigger list. So because it's not included in the trigger list, of course, this GitHub Actions is not running. So to fix this, we're going to have to make sure that we're pushing something that actually will trigger our GitHub Actions workflow. Okay. So what does your GitHub Actions workflow accomplish, and how does it enable reliable CI testing? The GitHub Actions workflow automates the semantic test that we've set up. It triggers when there are changes to the Kubernetes text file, the app file, or the embeddings file. The workflow uses mock mode to make sure we're automating deterministic tests, which enables reliable CI, continuous integration, because our test results are no longer influenced by LLM outputs. Nice. Okay, so we're gonna click done. Very nice. And you should be able to see all of these responses that you've been writing contribute towards a beautiful documentation that you can now share at the end of this project too, by the way. But yeah, perfect. We are going to, perfect. We're going to set up a working GitHub Actions workflow because, well, actually, I take it back. Our GitHub Actions workflow is already working. It's just that we haven't triggered it yet. So we're probably just gonna need to trigger it and then watch it run. Very nice. Okay. Next up, final step of this project, let's trigger our GitHub Actions workflow and watch those semantic tests fail. Because guess which document is still broken, but we haven't pushed that yet. That's right. Our Kubernetes text file still hasn't been pushed up to our GitHub repo. So once we push it, it's probably going to trigger our GitHub Actions workflow. And because we know that test is going to fail, you're going to see that workflow show the results that your tests have failed too. Okay, so in this step, we're testing our GitHub Actions workflow. Semantic regression means a degradation of the quality of our RAG API's responses And CI will catch this by testing the quality of the information in our knowledge base. Beautiful. So we're going to trigger that workflow now. Remember that from step 3, we already broke that Kubernetes text file by removing orchestration. So let's just push that change up, and we can do this by running git add Kubernetes text. And then we can run this command to commit the change. So we're writing that commit message. We're saying we're going to update that Kubernetes text file, and then we're going to push that up. Okay? So since you've changed a Kubernetes text file, GitHub Actions is going to detect the push, check out your code, set up Python and dependencies, rebuild those embeddings, start the API in mock mode, run semantic tests, and let's watch it all happen. Okay, let's watch it happen in GitHub Actions over here. And it's already running. Oh my goodness. You should see this appear and start running. Oh my gosh, and it is. Oh my gosh. Really cool to see it running now. You can even click into the workflow to see the details, see how it's going. And we can see test and build has failed. That's okay. Let's click into test and build and understand why it's failed. Surprise, surprise, missing the orchestration keyword. There we go. So our GitHub Actions workflow has successfully gone through all of these steps. Like it has installed all of your dependencies, it's set up Python, it's built your embeddings, started the API in mock mode, and it's just run that semantic test, and it's told us, hey, you're missing the orchestration keyword. So beautiful work to see our tests work not just locally, but even when we load our tests onto GitHub so that it's running on GitHub servers. What great validation that this test is working not just because of some sort of local setup. You know, even if we were to try to automate it and pass it to another server, it can still work perfectly fine too. So without continuous integration, let's say you have actually pushed your document and you tried to update your code with that document. What could have happened is you would have pushed this degraded content, it would have deployed to production, let's say, and maybe your RAG system will start to give incomplete answers. And you'd probably only notice it when users are complaining, aka when it's too late. So instead, in using this workflow, our CI has caught it in seconds before any harm was done. And in real production, this pattern scales to hundreds of documents and queries. You know, test that medical documents contain required disclaimers, verify legal documents have the necessary clauses, check that product docs mention some key features, or making sure that customer support docs cover some common issues. Semantic tests guard your RAG system's quality at scale, and it's very nice to see that not only did we set up these tests, we also automated it too. Beautiful. So let's take a screenshot of our CI and GitHub Actions catching that regression. Put that over here. And then we're going to define semantic regression and then how CI caught this. So semantic regression means the degradation of the quality of our RAG API or of our RAG system's responses. And CI caught this by running semantic tests. In production, this prevents semantic regression reaching our users and impacting their experience. Yeah? All right. Well done. You've built a complete CI/CD pipeline for your RAG API that automatically catches semantic regressions, and you've accomplished this full workflow. You've created semantic tests. It solves for non-determinism. You've automated testing, and you've also caught regressions. This is how professional teams maintain RAG system quality at scale. Every push is automatically validated, preventing degraded content from ever reaching production. Beautiful. So for our secret mission today, totally up to you on whether or not you're up for the extra challenge. And you know what? Over here at NextWork, we always are. So get ready to do the secret mission if you're keen. Otherwise, you're more than welcome to wrap up your project now. In our secret mission, we're going to be leveling up our setup by handling multiple knowledge documents to see how CI will automatically test them all. Right now, we can automatically test our Kubernetes text file, but what if we have multiple files? So that's what the secret mission is all about. Let's jump in and take a look. Whoa. Okay, so in this project, we're restructuring. Maybe I should zoom in a little bit so you can see this. I think this is the proper zoom. Okay, so in this project, we're restructuring I would say our knowledge base to include multiple documents, not just one. The docs folder structure helps by creating a repository of documents instead of relying on a single text file. That's a bit of a spoiler into how we're going to do this. We're going to be restructuring Kubernetes text file and creating a folder of documents where the kx.txt file is simply just one of them. So instead of a single text file, we're enabling scaling because we can now let our RAG API cover multiple concepts instead of just one. Nice. Okay. So let's organize our knowledge base. In your IDE, this starts by creating a docs folder. Whoa. So here we're going to create a new folder. You can also just press new folder up here. Type docs so that it's called docs. And then we're going to move that Kubernetes text file into docs so that it's now folded inside. See that you can hide and unhide it by clicking on docs. That tells us that it's inside that folder. And check that it's now inside the folder, it's no longer in the root. And once that's done, we're going to create a new embedding script. Because embed.py, notice how it just references the kx.txt file, one specific file, hard-coded. And we're going to want to make sure that our embeddings file can actually embed multiple documents without us needing to specify exactly what those documents are called, so on and so forth. We just want to say, hey, embed all of the documents in this docs folder. So let's create a new file in your project root and call it embed docs, like this. And we're going to go ahead and paste this content into our embed docs file. And this script, again, it makes sure that we're just going to go through everything in the docs folder and all of the text files in there and create embeddings instead of saying, hey, let's embed Kubernetes.txt file. You know, we're not hard coding that into our embeddings file anymore. So to make sure that this actually works, we're going to just run this in our terminal now and see what happens. Okay, so we're going to paste this command, python embed docs, and it tells us that it's re-embedded all the documents in our docs folder. The good thing about this is it automatically clears any embeddings as well, so we don't need to delete the DB folder every single time manually too. Okay, and now that we've got a new way of embedding, we're going to need to make sure that our GitHub Actions workflow is reflecting that too. Do you see anything that should change in this file? Well, all of these seem okay. This part, maybe not here. You know, we're no longer building embeddings with this file. We're now using embed docs Python. So this needs to change, and so does the trigger. You know, any file inside the docs folder should now be able to trigger your GitHub Actions workflow, not just Kubernetes text. And for embed Python, make sure that gets updated to embed docs as well. Okay? So these 3 lines that reference older docs that we no longer use are going to need to update. So off we go with updating our CI file, nothing else changes. It's really just those references. And then we can save that file and commit our restructure. So we're gonna go git add like this. We're gonna commit our restructure so that we're adding a docs folder and we're using this more advanced embed docs embeddings file. And then we're gonna push those changes. Beautiful. So watch the CI run with the new structure. It should pass. Let's have a look. So I'm just loading my GitHub Actions right now. And you can see that the action ran again just a minute ago, exactly when we pushed our changes, because embed docs have changed, and so did the docs folder, which triggered our actions workflow. Okay, so you can see again it got triggered, same error, missing the orchestration keyword, which we're like, all right, no surprises there anymore. But to really test our new system, let's add a second knowledge document to our RAG system. Beautiful. So we're adding a second document because we're gonna need to demonstrate that our new embed doc script can handle multiple documents, and that our RAG system can actually answer questions from different knowledge domains, not just about Kubernetes, and that our CI workflow can actually test all documents and not just one. So adding the second document is definitely going to put our new system to the test. And how we're going to do this is by creating a new file in that docs folder, and we're going to call that one nextwork.txt. Whoa. Let's rename that. Let's just make sure it says txt. Okay, and then we're going to paste this content into the file like this. And the content says, Nextwork is the world's best platform for learning and showcasing your AI skills. We're going to save that file, press Ctrl S, and then let's rebuild our embeddings and see whether or not our GitHub Actions workflow is triggered. So let's update our let's run the embedding script so that our embeddings are refreshed and this gets embedded too. And the information is now saved in our database, which lets us test the Nextwork document. We'll check if the API is already running. Okay, it's not. So we're just gonna open a new terminal tab in Cursor and just use the API in mock mode. Okay, there we go. Beautiful. Okay, so it's running now. Okay, so we're going to now switch over to the other terminal and test our API like this. Okay, and we can see Nextwork is the world's best platform for learning and showcasing AI skills. So we have a correct answer. We can now stop our RAG API running in the first terminal and update our semantic tests so that we can actually make sure that our semantic tests are testing for whether or not key concepts are showing up when we ask questions about Nextwork, not just when we ask questions about Kubernetes. So we're going to replace the entire contents of this file with a file that also contains test Nextwork query over here. So now we're also going to test, after we test Kubernetes, whether or not it's responding with the right answers about Nextwork. And in this case, the key concept is a special word. We haven't added this word into the Nextwork text file, but we're just going to test for that because it's going to force us to know whether or not this test will actually tell us if it's missing keywords in the Nextwork file. So let's replace the contents of this file with our new test Nextwork query, save it, and then we're going to commit and push those changes. Okay, so let's save this milestone in our semantic tests and in our Nextwork text file. And let's commit and push those changes. We're going to add the Nextwork semantic tests and the Nextwork document. and then we're going to push those changes. So let's go ahead, and now that we've pushed those changes, check out whether or not our GitHub Actions workflow has been triggered, because if it's been triggered, we should be able to see that in our next workflow run. Oh, I think this should also mention that we should also change our Kubernetes text file. So let's go ahead and actually fix our Kubernetes text file so that we no longer run into errors there, but we will still run into errors in the next work file. So my apologies. Let's go ahead and actually fix the Kubernetes text file so it says container orchestration platform. Save that and commit and push that change. Update the Kubernetes text file. And we just push that. The reason why we should fix our Kubernetes text file is because we don't want to see our workflow failing again because it's missing the word orchestration. We've seen that enough to know that it can detect that. What we still don't know is whether or not it can detect changes in the next work file and whether or not it can detect it when it's missing those keywords. So we are triggering our workflow again, this time making sure that it's actually going to test our next work file instead of the Kubernetes file. So here we go. All right, and as you can see, it has failed once more, but what is the reason? It's missing a keyword in the next work file, but the Kubernetes query test passed. Very nice. So that is great confirmation that not only can we handle semantic tests, but we can actually handle semantic tests over multiple documents. So the workflow failed, and we can also see that if we wanted to add more files, there's definitely like this infinite way to continue building your knowledge base now. Very good. Thank you so much. Let us wrap up these last few tasks and also check out our beautiful documentation. So let's upload a screenshot of this workflow testing multiple documents over here. Like this, chuck that in here, and the doc structure helps by putting all knowledge base documents into a folder, and the embed doc script processes all documents in the /docs folder. CI automatically tests all documents and caught that the new next work text file was missing a keyword. Restructuring our knowledge base enables scaling because we can now add multiple documents and test multiple domains. Well done. Okay. All done, and I think you are more than welcome to delete your resources. The good news is that actually everything you've built today is free to own, free to keep. So you can actually just keep everything without needing to pay anything. So this is a great chance for you to keep what you've built today and continue working on it so that you maybe have a RAG API that is on many different domains, or you can try to containerize your work today and still try to deploy things and see whether or not you can run these semantic tests even when it's all containerized or deployed onto Kubernetes. So lots of different avenues from here. We'll just wrap up together with that final reflection. Okay, so services we used in this project were GitHub Actions. We also used, what else did we use today? We also used, oh, this crossed me. We also used Ollama, Fast API, and Unicorn to build our RAG API and automate a testing workflow. Key concepts we learned include CI/CD, RAG testing, semantic regression, and non-deterministic tests. This project took us about 2 hours to complete. The most challenging part was understanding, spotting, and fixing non-deterministic tests. But it was most rewarding to see multiple files work for our knowledge base. Okay, so thank you so much for doing this project today. We did this project because we wanted to learn how GitHub Actions work and ways we can test a RAG API. One thing I'll apply from this definitely will be the concept of semantic regression. There are so many use cases, and it'll be interesting to see how different industries, we saw healthcare, we saw legal, do this. Are there solutions for a specific industry where people in that industry don't actually know about semantic regression and how we can use things like semantic tests to test it in advance? That would be interesting. Beautiful work, everyone. That's a wrap for today. You've just built a complete CI/CD pipeline for your RAG API with GitHub Actions, and you've learned how to set up Git version control. You've created a GitHub repo. You've structured your knowledge base, implemented mock LLM mode. You've built semantic test. There's a lot of things that we got to do today, didn't we? It's really, really exciting to do something so hands-on and something that is so relevant actually to what's going on today, with so many RAG apps coming out and people wondering like, hey, how can we control things like hallucination when we are actually pushing out all of these AI apps into the world, and we want to make sure that our learners our users have a great time. So congratulations. If you're ready to quiz yourself, this is an end of project quiz, and you can also check out your work right here to complete today's project. Cool. We're just gonna make sure everything is done. Okay, let's go here, click. Oh, we totally missed this, didn't we? Non-deterministic output means output with varying results. This is a problem for CI/CD because we lose trust in our automated tests, and they'll eventually become useless. Mock LLM mode solves this by taking LLMs out of the equation. We'll check what is the retrieved context instead of what is the generated response at the end. Nice. Okay, so I think that completes everything in this project. We're just going to double check one more time. Okay, there we go. We can now click mission accomplished and wrap up today's mission. Awesome. So thank you very much everyone for joining me in this project today. Don't forget to share your project on LinkedIn or share it on Instagram, share it on Facebook. We will would love to see you sharing your work. It's something to be very proud of, definitely. And there are lots of Nextwork learners sharing their work on LinkedIn too. So it's a beautiful community in Discord and LinkedIn. Definitely join us on Discord if you're not there already. And we love to learn with you. If you have any requests for projects, feel free to add them to the comments as well, or you can join the community and chuck them straight there. We love creating projects based on what people want to learn. And shout out to the learners that have actually requested something to do with CI/CD and GitHub Actions. I hope you enjoy this project and learn something great out of it. All right, thanks everyone, and catch you next time. Bye.